Good morning students. In this class we will cover design of multiplexer. In the previous class we have covered the introduction of multiplexer, that is what is multiplexer and what is the application of multiplexer and basic concept of 2:1, 4:1, 8:1 multiplexers. And in this class we will implement Boolean expressions using multiplexers. Now when you implement Boolean expressions using multiplexers, then keep one thing in your mind, that multiplexer designing can be of two types, direct method and indirect method. In direct method of multiplexer designing, the number of input line will be 2 to the power number of select line, right? But that is the size of the, if there are three variable expression, a, b, c, like this is the three variable expressions, then these three variables a, b and c will be given to the select line. So there are three select lines, so number of input line will be 2 to the power of 3, that is 8. So size of the multiplexer will be a 8:1 multiplexer. If we design it by using, if we implement this expression by using direct method. But in indirect method, the size of the multiplexer is just half, right? In case of indirect method, if we implement the same expression using indirect method, then we will be able to implement it by using just half size multiplexer. That is, in direct method we need to use 8:1 multiplexer, but if we design the same thing by using indirect method, then we will be able to design it by using 4:1 multiplexer, right? So in indirect method we will be able to design the same multiplexer, we will be able to implement same expression by using half size multiplexer. Size of the multiplexer is just half. In this class we will cover direct method of designing. In the next class we will cover indirect method of designing. So now let us see how to implement this expression by using direct method of multiplexer designing. So first of all we need to have the truth table. To design a multiplexer, first of all we need to have the truth table by using the Boolean expression. So how to design the truth table? There are three inputs A, B and C. So the truth table is, as there are three inputs A, B and C. So how many input combinations will be there? Obviously there will be 8 input combinations starting from 0, 0, 0 to 1, 1, 1. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. Right? Now what should be the output? For that, this y is our output. For that, we need to look at this minterm expression. Now see, what are the numbers mentioned in this minterm expression? 0, 1, 3, 5 and 7. Right? Now, decimal equivalent of these numbers, that input combination will have 1 and rest all will have 0. That means, see, 0, 0, 0. What is decimal equivalent of 0, 0, 0? 0. 0, 0, 1. The decimal equivalent is 1. 0, 1, 0. The decimal equivalent is 2. 0, 1, 1. The decimal equivalent is 3. 1, 0, 0. The decimal equivalent is 4. 1, 0, 1. The decimal equivalent is 5. 1, 1, 0. It will be 6 and 1, 1, 1. That will be 7. Right? Now see, what are the numbers mentioned? 0, 1, 3, 5, 7. Put 1 in those respective numbers. That is 0. So this output will be 1. Right? 1. So this output will be 1. 3. So this output will be 1. 5. So this output will be 1. 7. So this output will be 1. Now rest all the outputs will be 0. That means this is 0, this is 0 and this is 0. So this is the truth table, right? Truth table of this Boolean expression. So whenever you are designing a multiplexer, first of all you need to have the truth table from the Boolean expression. Then only you will be able to implement the circuit. Now we will implement this particular truth table by using multiplexer, right? Now what I have said that the select lines of a multiplexer. We know that select line multiplexers are having two input line. One is the original input line and another one is the select line, right? And the output line as usual. Now select line of the multiplexer will have these inputs A, B, C. The input variables will be given to the select line. Now as we are implementing by using direct method, what should be the size of the multiplexer? The size of the multiplexer will be 8:1. Why? Because as, see, this is my multiplexer, this is the MUX. Now if the select lines are A, B, C, this is given to the select line. These inputs are always given to the select line, right? So this is S0, S1, S2. Now as there are three select line, what should be the number of input line? That should be 2 to the power of 3, because number of input line is equal to 2 to the power of number of select line. So that is, as there are three select line, number of input line will be 2 to the power of 3, that is 8. Right. So 8 input lines will be there. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 input lines, and output line of a multiplexer is always 1. So Y is the output line. Right. So this is I0, this is I1, I2, I3, I4, I5, I6 and I7. These are the input lines starting from I0 to I7. There are 8 input lines and only one output line, right? So what is the size of the multiplexer? 8:1, right? So this is a 8:1 MUX. So whenever we are designing the multiplexer in direct method, then as there are 3 input lines, 3 input variables, those input variables are given to the select line. So the size of the multiplexer will be 8:1 multiplexer if there are 3 input variables, right? If there are 2 input variables, then those 2 input variables will be given to the select line. So in that case, what will be the number of input line? 2 to the power of 2, that is 4. So 4:1 multiplexer will be required, right? If suppose there are 4 input lines, if an expression is a 4 variable expression A, B, C, D, suppose it is A, B, C, D. So there are 4 variables. So in that case, number of select line will be 4. A, B, C, D. All these 3 input variables will be given to the 4 select lines. So in that case, what will be the size of the multiplexer? 2 to the power of 4, that is 16. 16:1, right? So let us concentrate on this 8:1 MUX. And why is the output line? We know that output line of the multiplexer is always 1. Now see how to connect the input lines so that we will be able to have this output. See, when A, B, C are 0, 0, 0, 0, 0, 0, right? Then which one input will be selected? 0, 0, 0 means decimal 0. So I0 will be selected and Y is equal to I0. Okay. Now what is I0? What is Y? For 0, 0, 0 input, what is Y? Y is 1. See, Y is 1. So what should be connected to I0? So that we get output equal to 1 for 0, 0, 0 input combination. Obviously logic 1. So I0 is connected to VCC or logic 1. VCC means plus 5 volt voltage in case of digital. So this is logic 1 and 0 means logic 0. 0 volt means logic 0. VCC is plus 5 volt, that is logic 1. Right. So I0 is connected to VCC. Right. Now see, when ABC is 0, 0, 1, then which one of the input will be selected? 0, 0, 1 means decimal 1. So I1 will be selected and Y is equal to I1. Right? But see, for 0, 0, 1 combination, what is the desired output? 1. So I1 should also be connected to VCC or logic 1 so that when ABC are 0, 0, 1, then Y is equal to 1. Right? So I1 is connected to VCC or logic 1. Right. Now see, for the next combination, that is 0, 1, 0. 0, 1, 0. So 0, 1, 0 means decimal 2. Right? So then which one of the input will be selected? I2. And Y is equal to I2. Right? Now see, Y is equal to I2 for 0, 1, 0. But see, for 0, 1, 0, what is the desired output? The desired output is 0. Right? So what should be I2? So that for 0, 1, 0 input combination, output is 0. I2 should be connected to logic 0 or ground. You may tell that ground. Ground is logic 0. So I2 is ground. GND means ground. Right? Or you can show it by this sign. This is a ground sign. Okay. Now see, next logic combination is 0, 1, 1. 0, 1, 1 means 3, decimal 3. So which one input will be selected? I3. Right? Now see, for 0, 1, 1, what is the desired output? 1. So what should be connected to I3? VCC or logic 1. So that for 0, 1, 1 input combination, output is 1. Right? So I3 should be connected to VCC. Right? Now the next input combination is 1, 0, 0. 1, 0, 0. Okay. For 1, 0, 0 input combination, which one input will be selected? 1, 0, 0 means 4, decimal 4. So I4 will be selected and Y is equal to I4. Okay. Now for 1, 0, 0, what is the desired output? 0. Right? So what should be connected to I4? Ground or logic 0. So it is grounded. This is the sign of ground. You can show this to show that this line is grounded. Okay. Now the next one is 101. 101 means decimal 5. So which one input will be selected? I5. Right? I5 will be selected. So Y is equal to I5. Now what is the desired output for 101? For 101, the desired output is 1. Right? So what should be connected to I5? VCC or logic 1. VCC. Now see, the next one is I6. For I6, the next input combination is 110. For 110 input combination, which one input will be selected? I6. Right? Because 110 means decimal equivalent of I6. So for 110, this is I6 then. So for 110 input combination, what is the desired output? Desired output is 0. So what is the connection to I6? I6 should be grounded or logic 0. So this is ground. Right? Now see, the last input combination is 111. For 111 input combination, which one input will be selected? 111 means decimal 7. So I7 will be selected and y is equal to I7, right? So what should be the connection to I7? See, for 111 input combination, y is 1. So what is the connection to I7? I7 should be connected to VCC or logic 1. So that when ABC are 111, then the output is 1. Right? So this is how we need to connect our inputs according to the K-map when we are designing a multiplexer circuit in direct method of multiplexer designing. Right? Now this is all for direct method of, this is one example of direct method of multiplexer designing, and in the next class first I will cover implementation of all the logic gates by using direct method of multiplexer designing. What are the implementation of logic gates like AND, OR, NAND, NOT, XOR, XNOT and NOT, and we will see how to implement those logic gates using direct method of multiplexer designing. That is a very important question in all the Viva exams. So we will first do that and then we will move to the indirect method of multiplexer designing. So this is all for today's class. Thank you so much for watching, and if you have not yet subscribed the channel, please subscribe the channel. Thank you.